Hello guys, hope you all are doing well. So in the continuation of the previous series, we are solving the GATE questions. So we were solving GATE 1990 question and today we have a new question. So without wasting time, we will go into the question. So I'll write here first, GATE 1990 chemical. Okay, so today we have fluid mechanics. Fluid mechanics. Fluid mechanics. Okay, question 12. Okay. So what question is saying? Water flowing at rate 1.5 liter per second. So flow rate of water 1.5 liter per second. We have to convert it into meter cube per second. So 1.5 uh, if I'll divide it by 1000 meter cube per second. How? 1 meter cube is equal to 1000 liter, right? So meter cube divided by 1000. We'll replace this liter, okay, with this liter. Okay, so this is in a 0.05 meter dia tube. So this is our pipe along with orifice meter and water is flowing. Okay. So diameter of pipe, we have diameter of pipe is equal to 0.05 meter. Okay. By means of a simple orifice of diameter of orifice is equal to 0.025 meter. If coefficient of discharge is 6.2 CD, 6.2, what will be the reading on mercury under water manometer connected to the meter? Density of water is 1000, density of mercury is given, and viscosity of water is given. Okay, so very first thing, what he is asking. Okay, so suppose we have mercury here. This is mercury, right? Okay, suppose this is mercury up to this point. Okay, see, this is water, and here will be water. Okay, so this height will be h, and this height up to this point will be x. So always remember 4 points in venturi meter and orifice meter. The first point is reading shows by flowing fluid. Reading shows by flowing fluid is represented by h. I'm not taking care of the spellings. Okay, and reading shows by manometric fluid. Manometric. It does not necessary that manometric fluid always be mercury. It could be different in some cases. Shows a manometric fluid is represented by x. So based on these two things, we have two other things to remember in these concepts. If manometric fluid, that is fluid inside the manometer, is heavier than flowing fluid, fluid which is flowing inside the pipe, flowing fluid, then we will use H is equal to X S heavier upon S lighter minus 1, and it could be written as, sorry, uh, density of heavier upon density of lighter minus 1 into X. I have forgot X here, so I will write here. Okay. And the last point in this concept is, if manometric fluid is lighter than water, oh sorry, flowing fluid. Suppose we have manometric fluid as alcohol. Alcohol density ranges from 850 to 950, in between the range density ranges. So water is flowing inside the pipe, and then alcohol is manometric fluid. Then we will use this formula. Which one? This one. Where it is? H is equal to X 1 minus S lighter upon S heavier is equal to X 1 minus density of lighter upon density of heavier. Okay, so in Venturi meter and in orifice meter we have to remember these 4 points. Okay, now in our question, manometric fluid is mercury, which is heavier than the flowing fluid, that is water. So we will use this formula. Now what question is saying? What question wants? What will be the reading on mercury under water manometer? So reading on mercury under water manometer. Okay. So the question is asking for X. The question is asking for X. X. We have to find X. Okay. So with this formula we have to find X. But for that we have to find H. Okay. So applying. So we have Q is equal to CD A1 A2 upon under root A1 square minus A2 square into root 2GH. Okay, that is Q actual. So Q actual is equal to CD into Q theoretical. That is the formula. Okay, but don't use this formula. Don't use this formula. This is a long formula, and first you will calculate A1 square, A2 square, then that is very lengthy. Okay, instead of this formula, use this. V0 is equal to CD under root 1 minus beta की power 4 root 2GH. Okay, V0 is the velocity at orifice. Velocity at orifice. Okay. In case of Venturi meter, it becomes VT, velocity at throat. CD, and everything will remain same. So for calculating Vt or V0, velocity at orifice or velocity at throat, we know that Q1, Q0 or Q at throat or Q at the end of pipe will all remain same. Okay, so Q naught is equal to A naught V naught, and we have Q, that is 1.5 divided by 1000 meter cube per second is equal to 5.025 square by 4 into V naught. On solving this equation, we will get V naught is equal to 3.06 meter per second. Put this value here. Okay, so we'll get 3.06 meter per second is equal to CD is 0.62 under root 1 minus beta. Beta is nothing but the ratio of diameter of orifice upon diameter of pipe in case of orifice meter, and diameter of throat upon diameter of pipe in case of venturi meter. So here diameter of orifice is 0.025 divided by 0.05, that will be equal to 0.5. Okay, so I'll write here 0.5 की power 4 into root 2. G is gravity and H we have to find H. Okay, so on solving this, H will come 1.163 meter, right? Put this value of H in this equation. Okay. Let's see what will come. So H is equal to 1.163 meter. We need to find X. 136 heavier fluid density upon lighter fluid density minus 1. So X will come 92 mm. Okay, 92 mm. Okay. Now remember when we will find H. If it is written in the question reading on water under mercury, if water will come first, we have to find H. If mercury will come first, we have to find X. Okay, so remember this. So hope you understand this question, and if you have any doubt, just comment it below. I'll clear it. But just remember 4 things. The very first thing is reading shows by the flowing fluid represented by H. Reading shows by the manometric fluid represented by X. If manometric fluid is heavier than flowing fluid, then we will use this. If manometric fluid is lighter than flowing fluid, we will use this. And the last one is always use V naught equal to Vt is equal to CD upon under root 1 minus beta ki power 4 under root 2 GH. Right? Always use this. Okay, so bye guys, take care.